Good afternoon, everyone. I'm DC from Group 1. Today, our group are going to present a proposal for the development and prototyping of a multi-cleaning purpose robot, MCPR. I will give a brief introduction, including the problem's technical dimensions and proposed solution. I will also talk about the literature review. My groupmate, Mickey, will discuss the technical description. And last but not least, my groupmate Hugo will explain the feasibility of the design and help us to conclude the presentation. Let's begin. Have you ever been annoyed when you still need to do housework after busy at work all day? While doing housework could be a time-consuming stuff, as well as its potential danger. Hardly could people have enough time to finish all the tasks. Therefore, the common way to address the problem is using the cleaning machines, like sweeping robot, vacuum cleaner, and window cleaning robot, to reduce the burden of housework and increase the safety. However, most of the household devices nowadays are single-purpose devices and limited by the function. People are required to buy more than one device so that it can have a more comprehensive household cleaning. The proposal will introduce a conceptual design of hybrid robot, MCPR, and explain its feasibility. In the literature, sweeping robots and window cleaning robots are two household devices commonly used for cleaning. Sweeping robot, composed of a spinning side brush and counter-rotate brushes, a stick-shaped machine controlled by Arduino microcontroller. The spinning side brush can clean along the raw edge, while the counter-rotate brush will act like a dustpan and broom to get rid of the dirt and dust. The red pad at the bottom can clean the remaining dirt and dust that cannot be cleaned by the brush, while it can automatically sweep the floor without any manpower for proper functioning. People still need to use the vacuum cleaner periodically because of the counter-rotate brush design. Some of the dust and dirt at the loops and corners should not be spread, and the pad will constantly dry, which causes the dust will not be cleaned. It illustrates that the sweeping robots still have shortage on floor cleaning, which means it still requires people to clean the floor by themselves sometimes to ensure the floor cleaning completely. So next is window cleaning robot. It consists of bumper cushions, the edge detectors, and fan motor, which can ensure the robot stays safely. Attached to the gas, the bumper cushion can detect robot surrounding to protect window frames, while the edge detector can enable the machines to identify the edge of the frameless dash. And there is a map system, which can record the route to help robots find out where have not been cleaned yet. The robotic window cleaning robot can help prevent the accident from happening when people are trying to wipe the window. However, the function of the robotic window cleaner is limited. People may not be willing to buy a specific product for cleaning the window due to the limitation of use. While the current solutions of the robotic cleaning have their own flaws, a multi-cleaning purpose robot, MCPR, is developed to provide convenience to public, which is presented by my groupmate, Mickey. Please.
DC for introducing the two current solutions and why our product is better. Now, let me talk about the mechanism of our MCPR. Our MCPR, which is made for cleaning vertical and horizontal surfaces, combine the components and functions of a sweeping robot, vacuum, and window cleaning robot. It is square with dimensions of 13 x 13 x 6 inches. The robot is mainly made up of plastic. It features a movement system, a mapping system, an air pressure control system, an attachment system, a cleaning system, a dust sensing system, and a control system. There are two buttons on top. They're the vacuum mode and the window cleaning mode. The robot also comes with security design and a mobile app for remote control. Regarding the mapping and movement system, ultrasound sensor, which is shown on the left-hand side of our PowerPoint, are used to detect the distance between obstacle and the MCPR to map out the floor plan. The information collected will be sent to identify to the shortest path for vacuuming. MCPR is also installed with a simultaneous localization and mapping software that updates the information on cleaning spots, which is sent to the control system to avoid unnecessary repeating cleaning. As for window cleaning, the sensors enable the robots to determine its current orientation and distance from the window frame. The robots then receive commands from the control center and determine its movements. The motion of the robot is provided by its wheel, track, suctions from the seating members, and the frictions with the surfaces. As for the air pressure control system and attachment system, a sensor, which is shown on the left-hand side of our PowerPoint, monitor the air pressure between MCPR's vacuum and also the window plane, which is sent to the control system. The system then instructs the vacuum pumps, which is shown on the right-hand side of our PowerPoint, to adjust the air pressure between the robots and the panels so that the robots can stick to the panels while remaining locomotive. As for the cleaning system, MCPR is installed with two chambers, one for water and the other cleaning agents, and also a dust bed. A rectangular cleaning cloth is attached underneath the chambers. All these are detachable. There are lids on the top of the refillable chambers and holes at the bottom of them to allow the contents to keep the cloth wet during cleaning. The dust bed stores dust and debris collected by the vacuum. Users can open the lid over it to take out the bag to empty it. The dust sensing system can detect the dustier spots and vacuum them longer during every cleaning cycle. It then sends data about the cleaner and uncleaned spots to the mobile app, so users can always keep track on the cleaning processes and the additional time required. The security design, essential for MCPR Windows cleaning mode, features a safety rope and a metal gripper, which can be locked on the jamb of the window frame. Users can tie the rope to the robots to prevent it from falling off. Next, we will talk about the charging of a robot. Because the robots will be wireless when using, so we need to charge it with a wire plugging into the hole of the robot and charge it for 6 hours before use. When using MCPR, users can choose between the vacuum mode and the window cleaning mode by pressing one of the two buttons on top. In both modes, the robot navigates with its movement system and finds the best path based on the commands sent from the control system, after the system had analyzed the data collected by the mapping system. In the vacuum mode, MCPR sweeps dust and debris on the floor and collect them with the vacuum controlled by the air pressure control system. In the window cleaning mode, users first need to tie the robots to the metal gripper with the safety rope. The air pressure control system and the attachment system then enable the robots to stick to the vertical surfaces, while the latter adjusts the amounts of pressure so that the robots can stick and stuck up dust on the window panel while remaining locomotive. Now, I will talk about the overall design of our robots. There are two chambers in front, as you can see, and there will be air pressure sensors after it. And on both sides of our robots, there is a movement system, which attached to the wheels and tracks. And also, the two circles in the middle of our pictures in the seating members and the vacuum pumps. and the two double circle is for the air to come out. And in the bottom of our robots, there is another vacuum pump which is for collecting back dust. And also there is two square in the bottom which is for the dust sensing. So now Hugo will introduce the feasibility of our MCPR.
Thank you, Miki, for telling us what is the technical description of the project. And I'm Hugo. I'm going to tell you how feasible this project is. First of all, to the social aspects, there are a lot of reports say that most of the respondents want a hybrid robot rather than a separated function one. A hybrid robot is the robot contains floor sweeping and the vacuum cleaning function. They want it simply because it's more worthy, right? So our project MCPR contains three major functions of home cleaning: vacuum cleaning, window cleaning, and floor sweeping. It's more worthy, right? So we believe that it will be more popularized in the future to the general public. So it's socially feasible. Another aspect is the economical aspect. Let me give you some data first. According to a report, the current sales submit, which is the highest sales in a day, is about 580 million Hong Kong dollars. It's a gigantic amount of transaction. It refers that the demand of this kind of robot is very high. However, surprisingly, this kind of robot is not popular in Hong Kong yet. Just like me, I don't have, and my family also don't have one in their home. So it refers that there is a very huge market potential for this kind of products. So we hope, or we estimate, that our product MCPR will be very popular, and it will be the benefits will cover the cost in the future. So it is economical feasible. And the third aspect is technical aspect. We are an engineer students, so we have get into a lot of courses like computer courses, mechanical courses, robotic courses, and we know how to do the programming, and we know how to group components together to form robots. So we believe that we have sufficient knowledge and skills to achieve this kind of invention. And other things is that we have participated in a lot of activities and competition, because just like the OCAM, Welcome Cam, and other robotic competitions, we have participated a lot of it. We know how to group a complete robots. And another reason is that the technology involved in this project, just like the ultrasonic sensor, like the dust sensor, like the fall prevention algorithm, and this kind of technology are so mature in the current market, which means that they are already very well developed, and we just need to buy them here and group them with our skills, and this is not so difficult that we can handle it. So it is technically feasible for us. And the fourth and the final aspect is the financial aspects. And just like I've mentioned above, the techniques and technologies involved is very mature, so they are rather cheap in the market and easy to be purchased in the market. So we can simply buy them cheaply and group a new prototype. So this is financially feasible. And in conclusion, our product MCPR is a new product to combining three of the major home cleaning function: vacuum cleaning, floor sweeping, and window cleaning. And this kind of products involve the technologies and system that we can handle it, because we have get into a lot of relevant courses and competitions. And as we have explored above, the socially technically, economically, and financially, this project is feasible. And finally, I hope that our project can help the Hong Kong citizens and the other global citizens to have a better and more convenient home cleaning experience and create a more hygienic environment for them. And that's all for our presentation. Thank you.